Hello everyone, welcome to AIT concept video. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is computer science engineering with data science as specialization. So my subject is software engineering. So today I am going to discuss about component based development in software engineering. So let's start. So I mainly divided the content into three parts. In the first part, I'm going to give an introduction and explain about the component based development. In the second part, I'm going to discuss about the component based model. And in the last and final part, I'm going to discuss about the advantages of this model, and also I'll also discuss the limitations of this model. So let's start. Okay. What is component based development? So, component-based development is a procedure that accentuates the design and development of computer-based systems with the help of reusable software components. With CBD, the focus shifts from software engineering to software system composing. Component-based development techniques involve procedures for developing software systems by choosing ideal off-the-shelf components and then assembling them using a well-defined software architecture. With the systematic reuse of coarse-grained components, component-based development intends to deliver better quality and output. Component-based development is also known as component-based software engineering. Object-oriented modeling results in plethora of fine-grained classes, objects, and relationships. It is very hard to discover reusable parts among these smaller units. The idea behind CBD is to integrate the related parts and reuse them collectively. These integrated parts are known as components. Component-based development techniques consist of non-conventional development routines, including component evaluation, component retrieval, etc. It is important that the component-based development is carried out within a middleware infrastructure that supports the process. For example, Enterprise Java Beans. The key goals of component-based development are as follows: save time and money when building large and complex systems. Developing complex software systems with the help of off-the-shelf components helps reduce software development time sustainability. Function points or similar techniques can be used to verify the affordability of the existing method. Enhance the software quality. The component quality is the key factor behind the enhancement of software quality. Detect defects within the systems. The component-based development strategy supports fault detection by testing the components. However, finding the source of defects is challenging in component-based development. Component-based development software engineering is a process that focuses on the design and development of computer-based systems with the use of reusable software components. It not only identifies candidate components but also qualifies each component's interface, adapts components to remove architectural mismatches, assembles components into a selected architectural style, and updates components as requirements for the system change. The process model for component-based software engineering occurs concurrently with the component-based development. Component-based development (CBD) is a component-based software engineering activity that occurs in parallel with domain engineering. Using analysis and architectural design models, the software team refines an architectural style that is appropriate for the analysis model created for the application to be built. CBSC Framework activities. Framework activities of component-based software engineering are as follows. Component qualification. This activity ensures that the system architecture defines the requirements of the components for becoming a reusable components. Reusable components are generally identified through the traits in their interfaces. It means the services that are given and the means by which customers or consumers access these services are defined as a part of the component interface. Component adaptation. This activity ensures that the architecture defines the design conditions for all components and identifies their modes of connection. In some cases, existing reusable components may not be allowed to get used due to the architecture's design rules and conditions. These components should adapt and meet the requirements of the architecture or be refused and replaced by other more suitable components. This activity ensures that the architectural style of the system integrates the software components and forms a working system by identifying the connection and coordination mechanisms of the system. The architecture describes the composition of the end product. Component update. This activity ensures the updation of reusable components. Sometimes updates are complicated due to inclusion of third-party. The organization that developed the reusable components may be outside the immediate control of the software engineering organization accessing the component concurrently. So, let's discuss about component-based model. So, the component-based assembly model uses object-oriented technologies. The object-oriented technologies that emphasizes is on the creation of classes. Classes are the entities that encapsulate data and algorithms. In component-based architecture, classes, that is components required to build application, can be used as reusable components. This model uses various characteristics of the spiral model. This model is evolutionary by nature. Hence, software development can be done using iterative approach. In component-based development model, multiple classes can be used. These classes are basically the pre-packed components. The model works in the following manner. Step 1. First, identify all the required candidate components, that is classes, with the help of application data and algorithms. Step 2. If these candidate components are used in previous software projects, then they must be present in the library. Step 3. Such pre-existing components can be excited from the library and used for further development. But step 4. But if required component is not present in the library, then build or create the component as per requirement. Step 5. Place this newly created component in the library. This makes one iteration of the system. Step 6. Repeat step 1 to 5 for creating n iterations, where n denotes the number of iterations required to develop the complete application. So this is the spiral model through which the component-based model is going to work. So let's discuss about the advantages. Reusability. Think of each component as a single Lego piece. You can reuse the same piece many times over many projects. Each individual piece is self-contained. It doesn't need to know what the other pieces do, and it doesn't depend on the structure of the whole. You can choose the piece you want, fit it together with other pieces, and build something really cool. So, testability. Testing components individually is much more manageable than testing an entire system all at once. If you select a single Lego piece, it's simple to test and make sure it works. Likewise, if you develop self-contained components and individual pieces do what they are supported to do, you can be pretty confident that they will fit together with all of the other pieces without any issues. So, efficiency. Using a component-based approach will speed up every step in your process. When components live in a central library, team members can use, add, or update them at any time during the process. As your component library grows, the rate of delivery will also grow as your cost and time to market go down. Eventually, project managers won't have to write requirement designers. So consistency. Having a robust component library ensures user experience consistency across all of your projects. Maintainability. Last but not least, component based websites are easier to maintain and less risk to evolve. Thank you.